All right, so here we're going to talk about some just some extras, right? So I had realized after recording those last ones that there's a few more things that we left out. So just some tips and tricks really is most of it. So the first thing I want to say is if you're ever having an issue with your TTR, one of the most common things that you could do, and this is what was done back in the day, and you just have to be careful with it, is to use an actual AC source and then a multimeter on the secondary, like this one over here, and you can measure your ratio that way. Now, what I would actually do is I would make sure that you measure there and there with your multimeter. You take that same multimeter and you go to the primary and you measure here and here. Okay, and the reason is don't use the two different voltmeters because you might get different numbers, and then your ratio will be completely off. All right, but it's also a good way to troubleshoot your TTR as well. You know, you use something that you can't make up those numbers. Okay, just like I said, be careful with it. This is a live source at that point, and it could be dangerous. Next thing I want to point out is if you're doing TTRs and you're having issues, don't forget that sometimes transformers might have load tap changers and de-energized tap changers. Okay. And they will affect your ratio. So just be aware, and sometimes you might actually have to go and verify what tap it's on. The next thing I want to talk about is, and this is something I didn't point out in the last ones, but primarily because we were doing vector diagrams, but is if you're looking real close at these, A to C coil connection here, what you would notice, and by the way, this coil, A comes in here and then C comes in all the way around. So that's my A phase coil. And oh, look at this. A phase over here is also, this is my A phase coil, right? A to neutral. And if you notice, okay, if you look at the vector diagrams, and it will work out this way every time, which is why engineers devised these are parallel lines, okay? And so all of the parallel lines, when you look at them on the vector diagram, they are the same phase. And I'm going to show you right here. A to B is right here. And if you look, A phase comes in right here and connects to the other B phase. All right. And then C phase, we're going to go with some purple here, is going to come in right here, and it goes all the way through and goes out to B phase. So C to B is right here, and there's that one right there. Okay, so this works on all of the transformers. You can go back and look at all my other videos that I had like this, and you can double check them if you want. But we're going to go through some more right here. So just some common ones that just obviously make sense, right? H1 to H2, X1 to H. This is a single phase transformer. They have to be in phase. There's nothing to argue there. Okay, so what about a delta Y? Well, we just did that on the last screen. So A phase. By the way, this diagram right here is how to do single phase TTRs and winding resistances, and this comes from AEMC's website. So if you're having an issue, I recommend going to their website. It's a really handy tool, and there's some ones later that you'll find out that it's actually really good. So let's look at delta Y. So on the delta Y, you've got A phase here, and they've actually identified that. That's the same as H1 to H3. And oh, how do we do that? Well, we go to X1 to XO, which is, oh, look at that. That's the same parallel line. And then C phase is over here, and here is the other C phase. And if you look at those terminals, that's these ones right here. And then the last one, let me get my blue out. This is my B phase here, and this is my B phase. And if you look at those same terminals, they're right here, okay? So you can do the same thing if you want for this. It will work itself out. But I just want to point out this parallel line trick, okay? So let's start looking at some other ones right here. We could go over this one. I'm not going to waste my time. But let's look at this. These are called zigzag transformers, and these really confuse people. And so what I want to point out here is their construction, okay? So as we were talking about one of our last videos, if this is my A phase coil, this is my polarity dot, this is the primary side, the way it's wound is we actually have two coils on the secondary, okay? And we have polarity dot and polarity dot. Now, one of these goes to A phase. The other one goes to and it gets flipped and turns into the other phase, okay? So if you're wondering where it is, well, let's look at our vector diagram. So we were talking about A phase here. So A phase is this coil right here. I'm going to get this out of the way because I drew it over all of their information. So they say A phase is all of this, right? Well, that's because the secondary is a zigzag, but it looks like kind of like a Y, right? But A phase is, so this is my A right there. This is the same parallel line, and this is actually our X1 connection, which is also A phase, right? Then that makes this A phase. But where's our other parallel line, the other half of that coil? Well, it's actually part of B phase, okay? And then if we look at, let's draw C in red. So C's right here, and here's the other half of C phase. And then where's B phase? Well, B phase is the horizontal line, and you can see it's right here, here, and here, okay? And so if you're ever testing these and you're having an issue, you could use the if you have like a three-phase TTR and you want to set it up, you could use this ratio right here. You could also, if you have a single-phase TTR, you could set it up exactly how they have it shown right here, that phase, use this. Remember, most of these are all phase to phase values, not phase to ground, so be careful of that. And then if you really are having a problem, what you could do is you could just actually split your coils up, okay? And you can go from this one to this one, and then you can redo it as this one to this one, okay? And then you should get ideally the same ratio. And then you could also verify your connections as well, okay? Last thing we'll say about this zigzag is that they're polarity respective, okay? So that means that the polarity dot on this end of B is the same as that end of B, which is the same as this end of B, okay? So you can see that this polarity dot is facing the X2 terminal, but this polarity dot is facing the neutral terminal, all right? So be aware of that.